A cosmic question. Have you ever gazed up at the night sky and wondered about the mysteries of the universe? Among the most fascinating is a simple, everyday puzzle. Why do things have weight? It's a question that has intrigued humans for centuries, from ancient philosophers to modern scientists. Why do things have weight? Why does the ground pull us down, and why do some objects feel heavier than others? It's something we experience every day, but rarely stop to consider. You pick up a rock, it feels heavy. A feather, light. But what's really happening here? The difference you feel isn't just about size or shape. There's something deeper at play. This property is called mass. Mass is a measure of how much matter is in an object, and it's what makes a rock harder to lift than a feather. But mass isn't just a number on a scale, it's a fundamental property of everything in the universe. For a long time, scientists were puzzled over why some particles had mass and others didn't. What made one thing heavy and another light? This question led to some of the most important discoveries in physics. Mass gives us weight because gravity pulls on it. Gravity is the invisible force that keeps our feet on the ground and makes apples fall from trees. The more mass something has, the stronger gravity pulls on it, and the heavier it feels. Without mass, nothing would stick together. Imagine a world where everything floated apart, where you couldn't stand, sit, or even hold objects in your hand. Mass is what allows the universe to have structure, from the tiniest particles to the largest galaxies. The answer to why things have mass lies in an invisible energy field that fills the entire universe. The Higgs Field, named after physicist Peter Higgs. This field is everywhere, even in the emptiest parts of space, and it's constantly interacting with the particles that make up everything around us. As particles move through the Higgs field, some interact with it more than others. The more a particle interacts, the more mass it gains. It's like moving through a crowd. Some people get slowed down, while others slip right through. This interaction is what gives particles and everything made from them their mass. This field gives particles their mass, a fundamental part of our reality. Without the Higgs field, particles would zip around at the speed of light, unable to form atoms, molecules, or anything solid. The reason you can stand on the ground, throw a baseball, or even exist at all is due to this field. It's the hidden mechanism that makes the universe tangible and real. The universe isn't just empty space, it's filled with something that gives everything its substance. Every star, planet, and person owes their existence to this invisible field. Over the next sections, we'll explore this concept in more detail, how the Higgs field works, why it's so important, and how its discovery changed our understanding of science forever. Get ready to dive into the invisible world that gives everything weight. Before we dive into the mysterious world of the Higgs field, let's take a moment to really understand what mass is. It's a word we use all the time, but what does it actually mean? Why do some things feel heavy, while others are light as a feather? And why do objects behave so differently when we try to move them? These questions are at the heart of physics, and the answers are more fascinating than you might think. First, let's clear up a common confusion. Mass and weight are not the same thing. Weight is the force that gravity exerts on an object, pulling it toward the ground. Mass, on the other hand, is a measure of how much stuff or matter is inside an object. If you were to travel to the moon, your weight would change because the moon's gravity is weaker, but your mass would stay exactly the same. But mass is more than just a number on a scale. It tells us how much an object resists changes in its motion, a property called inertia. Inertia is why it's hard to suddenly stop a moving car, or why a soccer ball keeps rolling until something stops it. The more mass an object has, the more it wants to keep doing what it's already doing. Imagine you're at the grocery store, pushing 2 shopping carts. One is empty, gliding along with barely any effort. The other is packed full of cans and bottles, and suddenly it feels like you're pushing a small car. That difference you feel is mass in action. The full cart is much harder to get moving, and once it's rolling, it's also harder to stop. This isn't just about shopping carts, it's a universal rule. Whether it's a train, a planet, or a tiny grain of sand, more mass means more resistance to changes in motion. Think about a bowling ball and a ping pong ball. If you try to roll both across the floor, the bowling ball takes much more effort to start and stop. That's because it has more mass, and therefore more inertia. The ping pong ball, with its tiny mass, is easy to flick and send flying. For centuries, scientists understood inertia and could measure mass, but they were puzzled by a deeper question. Why do different particles have different masses? Why does a proton have more mass than an electron? What gives mass to anything at all? The answer, it turns out, isn't found by looking inside the particles themselves. Instead, it's about the environment they move through. Just like a swimmer feels resistance from water, particles experience something in the universe that gives them mass. Imagine running on a sandy beach versus a smooth, paved road. On the sand, every step is a struggle, your feet sink and you slow down. On the pavement, you glide along with ease. The difference isn't in your legs, it's in what you're moving through. In a similar way, particles feel their environment, and that's what gives them mass. This revolutionary idea that mass comes from an invisible field filling the universe changed physics forever. And it's the key to understanding the Higgs field, the mysterious force that gives mass to everything we know. How does the universe give particles mass? This is one of the most profound questions in all of physics, and the answer takes us deep into the very fabric of reality. For centuries, scientists wondered why some particles are heavy, while others are light, and why some seem to have no mass at all. The solution lies in a mysterious, all-pervading field that fills the cosmos. Imagine an invisible ocean, the Higgs field, stretching across the entire universe. You can't see it, touch it, or taste it, but it's everywhere, surrounding us at every moment, even in the emptiest corners of space. This field is as real as the air we breathe, yet it remains hidden from our senses. The Higgs field has been here since the very beginning, since the Big Bang itself. As the universe expanded and cooled, this field emerged, quietly shaping the destiny of every particle that would ever exist. It's not just a background feature, it's an active participant in the cosmic story, affecting everything that moves through it, from the tiniest electron to the largest star. To understand how it works, picture yourself walking through water. The water slows you down, making it harder to move. In the same way as particles travel through the Higgs field, they experience a kind of resistance. This resistance is what we perceive as mass. The more a particle interacts with the field, the heavier it feels. Some particles, like the top quark, interact very strongly with the Higgs field. It's as if they're trying to wade through thick, sticky honey. They feel a lot of resistance and end up with a lot of mass. Others, like electrons, interact less and move more easily, so they have less mass. And some, like photons, don't interact at all. They glide through the field effortlessly, remaining massless. Imagine the difference between running through air and running through water. Some particles are like sprinters on a track, barely slowed down, while others are like swimmers pushing through a pool. The amount of resistance they feel determines how much mass they have. The Higgs field is the source of this resistance, weaving an invisible web that connects every particle in the universe. It's what makes the universe an interconnected system, where the properties of even the smallest particles are linked to the vast cosmic field that surrounds us all. Without the Higgs field, particles would have no mass at all. Atoms wouldn't form, stars wouldn't shine, and the world as we know it simply wouldn't exist. The Higgs field is the silent architect of reality, giving substance to everything in the universe. Imagine a crowded party. The crowd is the Higgs field. Moving through it, you interact and slow down, gaining social mass. A celebrity, like a heavy particle, interacts strongly, facing more resistance. A lesser-known person, like a lighter particle, moves more easily with less interaction. Someone unknown moves freely, like a massless particle. This analogy explains how particles interact with the Higgs field, gaining mass. The Higgs field gives mass to many particles, but some, like photons, don't interact with it at all. Photons, particles of light, are massless, traveling at the universe's speed limit, the speed of light. Massless particles like gluons also don't interact with the Higgs field. This selectivity shows the Higgs field's role in the laws of physics, interacting only with certain particles. For decades, the Higgs field was a theory without proof. Scientists needed evidence, a particle, the Higgs boson. Finding it would confirm the field's existence, like seeing a ripple in water. The Large Hadron Collider, LHC, was built to create the Higgs boson by smashing protons together. In 2012, scientists announced the discovery of a new particle matching the Higgs boson's properties. This confirmed our understanding of the universe, completing a crucial piece of the puzzle. Why is the Higgs field important? Without it, the universe wouldn't exist as we know it. Without mass, particles wouldn't form atoms and there'd be no chemistry or elements. The Higgs field allowed structure and complexity to emerge, enabling stars, galaxies, and life. When you feel an object's weight, you're feeling its interaction with the Higgs field. This invisible field is the foundation of our reality, allowing galaxies, stars, planets, and people to exist.